What is an aurora? On Arctic nights, the aurora flames cross the sky as a beautiful display of lights. What is it, and how does it appear? The answer is our ever-changing sun, with energy being constantly created deep inside its core. High temperature and pressure provide enough conditions for a nuclear reaction to take place, where hydrogen atoms are put together to create helium, followed by a release of energy. The light scatters away from the core and towards the outer layers, where the heat slowly comes to the surface in huge eddies, also known as convection cells. Those cells are the electrical currents or charged gas molecules that are able to create magnetic fields inside the sun. There are some cases where the magnetic fields manage to push their way through the surface. They accelerate the eddies, and, as a result, the surface cools down and darkest sunspots dot the sun's external layer.
The electrical charged gas is known as plasma. It drags the magnetic field further away from the surface. The further the field is, the more it stretches and twists, similar to a rubber band before finally breaking and entering the outer space. This occurrence is followed by several billion tons of plasma being cast out of the sun.
Depending on the amount of energy released, the phenomena can be called either the solar wind or the solar storm. It takes 18 hours for the solar wind to reach the Earth. Unlike Mercury and Venus, the planets that the wind passes by before Earth, our planet has its own magnetic shield. It acts as some sort of an invisible shield deflecting the solar wind. The magnetic fields collide, creating a peculiar funnel for the gas to stream down. The aurora that appears on the daylight side of the poles is the daylight aurora, but the magnetic fields don't stop here.
They stretch farther back and couple together. The magnetic rubber bands snap, allowing the gas from the solar wind to stream along the magnetic lines. The aurora that appears on the night side of the poles is the nighttime aurora.
Additionally, if the aurora appears in the northern hemisphere, it will be called aurora borealis or northern lights. If the aurora appears in the southern hemisphere, it will be called aurora australis or southern lights. The particles from the solar wind bump into the ones that are in our atmosphere. Depending on which gas molecules the particles interact with, the aurora can acquire different colors. If the particles bump into oxygen, the reaction makes red and green light. When the particles bump into nitrogen, the reaction makes blue and purple light. And that's how aurora appears.